All right, guys, so thank you for joining me. My name is Egon Trujillo, and I'm going to be presenting to you my action research project for my Capstone seminar class. So I'm going to share my screen with you now and walk you through the process of what I researched. So here is my PowerPoint, and what I'm going to do is first just kind of set the stage for you a little bit. So for this class, what I've been trying to get a grasp on is how to engage science students, in particular, not just in Franklin, but like in general, because as time progresses, we probably know that engagement in science and mathematics, in particular, with time decreases, right? So that was kind of like the hook for me and why I wanted to undertake this project for myself. So I'll just start with my objective slide, and I'm following a 5E model for my objective. So I'm going to start first with an overview of what student engagement looks like, in particular for a science department like we all are. Then I'm going to explain what science engagement looks like in my own classroom and kind of the motivation for my research. And so I'll pose that as a research problem. Then I'll elaborate on my literature review and kind of what other experts are saying in the field of science engagement. Then I'm going to explore an intervention tool that I came up with, nothing novel, but something that I thought really worked well for my particular class. And then I'm going to do an evaluation of how I think it went for my students. Okay, so first, student engagement. I think it's no surprise to any of us that as time goes by, students not only aren't engaged, but if the curriculum, the teacher, or how we're making them feel isn't motivating them, then they're definitely not going to be engaged or much less motivated. And so looking at our school's data, I pulled up the California Science Test, or the CST data from last year, just to give you an idea of what we're looking at. So this is our CST data for last year. And you can see that last year, and again, this is for the district as a whole, right? So Franklin is not an island. So you'll notice that in the data, overall, in life sciences, physical science, and earth sciences, the number for students that are exceeding is very low, 5.86%, right? And in case you don't know, the CST is given to our juniors, right? So this is our population here. So only 5.86% of them are actually in the exceeding, and you'll see that 61% overall are just barely, getting there. All right, so that's an alarming number for us as a science department. So what can we do about it, right? So that was kind of the motivation for me wanting to explore this in my own class. So in my own class, I picked 3 focus students that I'm going to give the pseudonym of IG, DR, and MP. And by looking at Schoology and whole child data, I found that not only are these students struggling on NGSS and Common Core state standards for my classroom for science literacy and NGSS standards, but also they're struggling with engagement overall. So what I did was I first pulled some data from my own classroom. So this is Schoology data. And I implemented a couple of short assessments. So first I did a little entry ticket on the unit that I was introducing to them on cell cycle, mitosis, and cancer. And I gave them a quick little entry ticket as a formative assessment, and these are the 2 standards that I hoped to measure through that entry ticket. And you'll see here that you know about 3/4 of my students actually met that standard, right? Um, those focus students I was talking about. So here is I, here is D, and here is M. You can see that out of a total of 30 points. All 3 of them scored the lowest in the classroom at half the grade. Then I also gave them an annotation assignment on cancer for the same unit. Again, out of 80 points, you'll see that I, D, and M, so here's M and D, sorry, your faces are in my screen. And here's D. So you can see that they scored, again, very, very low on those assessments for those standards. But you'll also notice that I looked at whole child, And this is my classroom for this biology class. There's 24 students in that classroom. And you can see that of the ones that are at risk, I only have 4 that are showing in my classroom and being at risk. And it just so happens that 3 of the 4 are actually my focus students. So there's kind of a little pattern there between whole child and what my data is reflecting, right? So that obviously stood out to me. But then I dug a little further and I looked at, well, it could be a couple of things, right? It could probably be the curriculum, like I said, it could be the teacher, it could be how I'm making them feel, it could even be the time of day. So I explored a little further and I looked at whole child data for last year, same period. And you'll notice that for student I, for last year, same period, the class average for that whole class was S, and he is scoring U's throughout. So that told me that there might be something more to this. It may not just be the curriculum, it may not just be the teacher, it may not even be the time of day, right? So I thought, okay, there has to be a way that I can connect with some of these students. So what I did then is I did a literature review on science, engagement, and motivation. And I found 3 major theories on how to engage students. So Patel, Patuch, Steingut, Vasquez, Yates, and Kennedy talk about something just recently called agentic engagement theory. And what they tell us is that not only are students engaged because of the emotions they're feeling, their behavior, or even cognitive abilities, but there's this other fourth aspect of engagement called agentic engagement. And they're saying that's what really motivates and engages them. And they define agentic engagement as how proactive and constructive students are in the classroom, and that in turn motivates them. But then I also found that Heatley and Yotruba Durzel said that it's relationships with parents, with teachers, that truly are what engage and motivate students in the school. And then the last big theory that I researched was something called self-determination theory. And Deemer and Smith tell us that this tells us how the classroom, the curriculum, all play a part in how a student is engaged because of our ability to make them feel autonomous, competent, and connected to what they're learning. And so part of my research was kind of melding what all 3 of these research studies said to see how I could use that for my own classroom to address those focus students, right? So using that literature review and these 3 different theories, I came up with a problem that I was going to investigate and a research question that I hope to address. So from there, I thought, well, in the past, I've used PBLs. So I was posing that a good intervention tool for myself to engage students would be PBL. Why? Because PBL allows students to use tools such as technology in the classroom. And in case you guys aren't aware, PBLs, as stated by Ferreira, are a theoretical framework that is a constructivist pedagogical approach to learning in which students work together to find solutions to a complex problem, meaning that they learn as they do, right? Versus just lecture, right? So the cool thing about PBLs is rather than front loading information, students get to discover as they're doing and learn the information. So that's what PBLs are. And the other highlight about PBLs is that they promote problem solving, analytical skills, reasoning skills, and all that. If you look at the literature review, pretty much is what self-directed learning is. So in my mind, I thought, well, PBLs would be a really good way to make my students more autonomous. So I then went one step further and thought, well, because we are a one-to-one school, what better way to use PBL than with technology? So why technology? Well, Higgins and Bushell tell us that technology has the power to make students feel autonomous, which is key to motivating and engaging them. And now with the COVID pandemic, we're all using technology, of course. We're using it to solve problems. We're using it to express learning. We're using it to motivate, to engage, foster supportive and caring environments like we're doing. Lots of apps that have been introduced to us over the past 3 weeks, like Zoom, iExcel, PBS, BrainPop, etc. But before the closure, were we all using technology to its fullest potential? And I would argue that I don't think we were. So this project that I'm about to show you is actually something that I rolled out early out in the spring semester, and we just completed it. And so the project basically is this. I wanted to try to answer this research question. And the research question is, how will the implementation of technology impact student engagement and motivate students in my biology class? So it's a general enough question, but the intervention tool in particular is technology, and the outcome I was looking for is student engagement. Okay, so in order to do that, I broke down my research into the following three domains. I came up with an action and assessment plan. I then implemented it and looked at some significant findings from the implementation. And then I reflected as far as what my next steps would be so that I can continue this type of learning, not just for my students, but for myself. And so let me share with you now what the action plan was. So for that action plan, I focused on those three students, like I said, I, D, and M. And what I did for the class is I implemented an intrinsic motivation inquiry survey to confirm whether or not they're not motivated, or like I had said earlier, there's other external factors that be at play. So here is the actual link for the IMI survey that I gave to my students. And once I gave them that survey, I had an idea for what could be really the root cause of the lack of motivation. So that was the first step. Then after that, I introduced them to this PBL multimedia project that I was going to have them do on their iPads using that technological tool as a device to record, sketch, illustrate, animate, type, or design a solution to a cancer problem that we'd been studying early on in the spring semester. And so then what I did was I taught my students how to use various applications on their iPads, such as iMovie, a stop motion app, a sketchbook app, Google Drive, Google Docs, Google Slides, Google Sites, and YouTube. And I'll show you those projects at the end. And then lastly, once they were introduced to the PBL and learned how to use the various apps for the project, the culmination was a presentation to a panel of judges, which they completed about a month ago. So that was my plan for the project. The assessment, so once I told them about the project, I wanted to come up with a way to triangulate the data, meaning I wanted to make sure that just because one student did well on the project, I wanted to see if there were other ways that I could collect data to make sure that everyone was truly engaged. So the way I triangulated was I did participant observations, I did the pre-survey I showed you, but I also did a post, and then I did student interviews. And from the participant observations, I just did, formal in-class observations where I walked around, listened to conversations, looked at the kinds of interactions that these student groups were having. From the survey, and that is the actual link you can see, students were saying that before doing this technology PBL, a lot of them felt like they didn't have a lot of choice in classes in general when it came to assignments. A lot of them didn't feel connected to not just my class, but science class in general. They didn't feel too connected. And the post data shows that after having done this technology-based PBL, they felt like they had more choice. They felt like they had more voice because they could express themselves in multiple modes. And they connected because even the interviews showed me that students were saying they were more comfortable using technology than probably the adults in the classroom were, because technology now is a part of their life. And now, as we know, our whole class and our whole school has gone online. So from interviews, I found that working with technology was really powerful for students. So that was my assessment plan. This is how I collected data to confirm whether or not my intervention tool worked. From implementing it, I found three really big findings that I think are important and support what the experts said in my literature review. So my first big finding was that I saw students becoming more connected to the content because technology was allowing them to become engaged. And that engagement sparked curiosity in them. I also found that students demonstrated competency, and so did I over time, of technology usage. So, for example, when I taught students how to use iMovie, as you'll see later on, they created films that were not only high caliber, but worthy of being on any one of our PD websites. They also learned how to use apps and taught each other how to use these apps. And so my last major finding was that students became autonomous and self-directed learners in my class because they were teaching themselves from doing participant observations. I would hear students telling things to each other like, yeah, I've done projects like this. Let me show you how to do this. I created a discussion board assignment where they could like post their reflections and their progress for their assignments. And you could see in those observations that they were kind of just taking charge of this project by themselves. And the end result was high caliber technology based PBL projects, which I'll share with you. So those are my three significant findings. And as you can see, a lot of what I found kind of echoes what those researchers in my literature review were telling us is important to make self-directed learners. And that is that students are becoming autonomous, students are becoming competent, and that students are connecting to the biology content they're learning. And this is the true Google site. So if you'd like to view it on your own, I'm posting it there, but this is a website. So I showed all my students how to use Google Sites. And the project, like I said, was about cancer, and I let them choose any particular cancer from a list of cancers to choose from. And so all of the projects are of a different cancer, and I gave them that voice and that choice for how to express their learning. So this is a Google site for lung cancer that one of the groups created. Here is a YouTube video that students created using a sketchbook application that I embedded into our iPads. And that is the real link if you want to see those for yourself. And so, having completed all those projects, I then reflected on what it is that I learned. And so what I found was that my triangulation of data told me that technology truly impacted student engagement in a positive way. I found that students' needs to be autonomous, competent, and connecting to what they're learning was definitely met, as evidence in the surveys that I'd like you to take a look at, and even in the projects that you can see for yourself. But it left me with a couple of questions for myself, and that is, given the state of emergency that we're in now, my big question for myself and for you and for all departments is, well, can these technology-based PBLs engage all students across all disciplines during these school closures? But in the meantime, what I'm going to do is continue designing technology-based assessments like this using remote learning modules so that I can continue and can not just continue engaging students, but giving students opportunities to express their learning in different modalities. So that was a really important next step that I came up with. And these are my references, and like I said, this is the latest CST data, and these are all of my sources that I cited in my research. So, did you guys have any questions for me? So you can unmute yourself now.
I have a question.
Yes.
I love what is the IMI survey? What does it stand for again?
Inventory motivational, and that's intrinsic motivational inventory.
Right. I would have loved to have seen the questions.
Oh, you want me to share those with you? I can share them with
Yeah,
you.
I
Yeah,
would love
yeah,
to see what
yeah.
those look
Absolutely,
like. And
absolutely.
then the follow up as you're doing that is I would like to have seen like the results from that first survey. And then this is something, if you had given it again at the very end of the project to see what they answered again as a comparison.
Yeah, yeah, I did. That's yeah, I did
Oh,
the pre and
perfect.
post. Yeah, yeah. So
Great.
let me pull that up for you. Um, so let me share this with you. Did you have any other questions in the meanwhile while I pull it up?
That was my two.
Okay.
That was very nicely done.
Yeah, it was really good. I
Very
have a question about the focus students.
Yes.
So when you did this group PBL, did you assign groups for the students or did you let them choose?
Um, Typically on PBL projects, I use reciprocal teaching groups. So I make sure that every student has a role in it.
Okay.
I do choose groups, in particular, just because I had some struggling students on a project like this. I didn't think it'd be the best idea to kind of let them choose their own groups.
Mm-hmm.
And so, yeah, I did choose them, but they were purposeful and
Okay.
they were reciprocal teaching groups.
Mm-hmm.
So let me share with you now, Mr. Monteleone, the data.
And then those questions came from the survey. You just put them into the
Yes, yes,
Excel.
yeah. Let me pull that up for you now. But for the sake of time, I'm going to end the formal
Oh
presentation
yeah,
here,
yeah.
and I'll edit it.